In this video, we'll learn how to use schematic diagrams to help us solve for the sides of right triangles. In the diagram that we have in front of us, we have a large right triangle. That would be this right triangle. And then from this vertex of the right triangle, we see an altitude that's drawn to the hypotenuse of the large right triangle. That altitude divides the hypotenuse into a short part and into a long part. That altitude also divides the large right triangle into two smaller right triangles. There's this right triangle, which is the small one, and then there's the middle-sized, slightly larger right triangle. All three of these right triangles, the small one, the middle-sized one, and the large one, are all proportional to one another. They're all similar. And so we can set up proportions to solve for the sides of the right triangles. The method that I'm going to be using is to use a schematic to help us remember what proportions it is that we can write in order to solve the right triangle. The first schematic starts here at the left-hand corner of the hypotenuse, and then it includes the altitude of the hypotenuse, and then it includes the altitude again, and then it includes the longer side of the hypotenuse, the longer part rather of the hypotenuse. So just to reiterate, the first schematic, right, is going to give us a proportion. It's going to give us the short part of the hypotenuse divided by the altitude will be equal to the altitude divided by the longer part of the hypotenuse. Our second schematic starts at the left corner again of the hypotenuse of the large triangle. It goes across the whole hypotenuse of the triangle. Then it goes up the longer leg of the large right triangle, comes back down again the longer leg of the large right triangle, and then finally includes the longer part of the hypotenuse. Again, that's going to help us to write a proportion. The way that works is it's going to be the length of the hypotenuse divided by the leg of the large right triangle is equal to the leg of the large right triangle divided by the longer part of the hypotenuse. Our third schematic starts at the right-hand corner of the hypotenuse. It includes the hypotenuse of the large right triangle. It includes the other leg of the large right triangle. It again includes the other leg of the large right triangle, and it includes the shorter part of the hypotenuse. So to reiterate that schematic, it's going to help us to write a proportion that looks like this. It's going to be the hypotenuse of the large right triangle divided by the shorter leg of the large right triangle is equal to the shorter leg of the large right triangle divided by the shorter part of the hypotenuse of the large right triangle. Let's do an example. Suppose that the hypotenuse of the large right triangle is divided into two parts. The shorter part is 3, the longer part is 5. So now we're going to use the first schematic, which if you recall looked like this. Okay, and so this part would be 3, and this part would be 5, and the altitude we'll say is h. So the proportion that this helps us to write is 3 over h is equal to h over 5. So our second example of the second schematic, suppose that we call this leg of the large right triangle x. And so our second schematic looks like this. The entire hypotenuse, the leg of the right triangle, the leg of the right triangle, and then the longer part of the hypotenuse. And the proportion that this allows us to write is 8, which is 3 plus 5, the length of the whole hypotenuse, divided by x, is equal to x divided by 5. And now let's suppose that we want to find the other leg of the large right triangle. So just to refresh our memory, the short part of the hypotenuse was 3, the long part of the hypotenuse is 5, and that means that the entire hypotenuse has a length of 8. And let's call the other leg of the hypotenuse y. So our third schematic includes the entire length of the hypotenuse. Then it includes the length of the leg that we're looking for. And again, the length of the leg we're looking for, and then the short part of the hypotenuse. And so the proportion that we can write using this schematic is the entire length of the hypotenuse, which is 8, divided by y, is equal to y divided by 3. So in our next videos, we'll do more examples where we'll actually solve these proportions and figure out what the sides of the triangles are.